Imagine sitting in your living room, holding your phone, entirely unaware that someone parked outside is silently capturing every text and website you visit. That 5G icon at the top of your screen is purely a measure of signal strength. It offers no confirmation about the identity or the security of the hardware you are actually talking to. Here is a foundational flaw in mobile engineering. Your smartphone is programmed to be obedient. When searching for a network, it blindly connects to whichever cell tower provides the strongest physical signal nearby. It drops the real network to grab the louder one. Because the hardware prioritizes speed and convenience, it never verifies if that loud signal is legitimate. That engineering choice turns mere physical proximity into a severe security vulnerability. Bad actors exploit this exact weakness using devices called Stingrays. These fake cell towers broadcast an overpowering signal, tricking every phone in the immediate area into connecting to them instead of the actual cellular network. For years, building a fake cell tower required specialized, highly restricted hardware that cost upwards of $50,000. The only people using them were law enforcement and intelligence agencies operating out of classified command centers. Today, the economics of surveillance have crashed. Anyone with basic technical knowledge and $2,000 can purchase off-the-shelf components to build a homegrown version in their garage. Once your phone is captured by their fake tower, the attacker sits squarely in the middle of your connection. They intercept all your data and calls, log what they want, and quietly pass the traffic along to the real network. You never see a drop in service. What used to require a massive federal budget is now accessible to a malicious neighbor, a private investigator, or a stalker. Digital espionage has moved out of the hands of nation-states and directly into our local neighborhoods. You might be wondering, aren't modern 4G and 5G networks heavily encrypted to prevent exactly this kind of identity theft? To keep you anonymous, modern networks use a radio network temporary identifier, or RNTI. It's a temporary mask for your phone, so your real identity isn't floating through the airwaves. But looking at this data flow visualization, you can see a fatal flaw. To get that temporary mask, your phone first has to introduce itself. The very first handshake frame a phone sends to join a tower transmits its permanent, unique hardware identifier entirely unencrypted. If a nearby fake tower captures that single initial frame, the attacker immediately extracts your permanent identity. They now have your unique hardware footprint and all the unencrypted network metadata attached to it. The most advanced network encryption in the world offers zero protection if the system architecture demands that you reveal your true identity just to open the door. Exposing these invisible traps requires turning their own rules against them, using a cheap piece of hardware called a software-defined radio, or SDR. Plugged into a laptop, it lets you see the invisible radio frequencies bouncing around your neighborhood. By scanning the local spectrum between 600 MHz and 3 GHz, you can force the software to log the presence and frequency of every legitimate cell tower currently operating in your area. In rural areas, you'll mostly find lower frequency towers, pushing slower data over vast distances. In a dense city, you'll log dozens of high-frequency towers built to handle massive localized traffic. This radar map shows exactly what you are looking to build, a normal baseline. For every blip, you log 2 critical pieces of data: the signal strength and the unique cell ID that legitimate carriers legally assign to their towers. Once you have your baseline, you simply watch for anomalies. If you run a scan the next day and a massive, overpowered signal suddenly pulses onto your map, completely dominating the local area, and notice it has no registered cell ID attached to it, you've found the trap. An incredibly strong signal appearing out of nowhere without an ID is the definitive signature of a fake tower actively hijacking phones. The airwaves surrounding us aren't an impenetrable black box. By methodically mapping out what is normal, regular citizens can strip away the invisibility of rogue towers and pinpoint the exact frequency of an interceptor. You might assume you're safe if you only use encrypted apps like Signal or WhatsApp. Do they protect you from a fake cell tower? Yes and no. End-to-end encryption successfully scrambles the actual words of your text messages and the audio of your calls. The attacker can't read what you wrote. But encryption does absolutely nothing to hide the surrounding network metadata. Looking at what a fake tower actually extracts, the content is scrambled, but everything else is in the clear. The attacker gets your permanent identity, your exact physical location, the timestamps of your activity, and the identity of the specific person you are communicating with. securing the content of your message is largely insufficient if the network still broadcasts the context, location, and participants to anyone listening nearby. Our modern mobile system operates almost entirely on a blind trust architecture. It resembles the wildly insecure, unencrypted Wild West of the early internet in the early 2000s, where simple hacks yielded massive amounts of private data. In a system built on blind trust, privacy is earned through technical vigilance, knowing which signals are normal and which ones are designed to deceive. Understanding the unseen network is the only way to effectively watch it back.